All right, for this presentation, we're going to do some computational analysis. The idea is I tried to pick a very simple database here to do the numbers on. You'll have to take some good notes on things to make sure you get this down and hopefully understand it. So we need to get an F ratio. That's the goal here. So in order to do that, do you remember what we have to do? We have to get the variance between groups, and we have to put that over the variance within groups. So we need to have a formula. Your book has all these detailed formulas. I'm going to try to kind of take it my own way here. It does match with what the book says, though. But what we basically need to do first is get the variance between groups. So we need a formula on how to get variance between groups. Remember, the basic idea for variance is sums of squares over degrees of freedom. So to get the variance between groups, we need the sums of squares between groups over the degrees of freedom between groups. So the first thing you need, and your book gives you a complicated kind of formula. Well, it still might be complicated, but the formula for the sums of squares between groups. That's what we need. And I wrote out the formula there. Sum of n times the quantity x bar minus x bar bar quantity squared. So you're probably asking, what do those x bars and x bar bars stand for? X bar represent each group mean. So what is the mean of the first group? 6. What is the mean of the second group? 2. So 2 and 6 represent the two x bars. X bar bar stands for the grand mean. You could just have the term grand mean in there if you wanted to. The grand mean is the mean of all the scores. So what is the mean of 1, 2, 3, and 5, 6, 7? Hopefully you came to the conclusion that the grand mean is 4. So what we need to do is we need to do the following. We need to do the summation of n. So what is little n here? How many do you have in the first group? We have 3. So you might do 3 times the quantity, and then the first group mean 2 minus 4 quantity squared. It would be 3 times the quantity, 2 minus 4 quantity squared, plus the other group, 3 times the quantity, 6 minus 4 quantity squared. So it's you take the number in the group, you get the mean of one group subtracted from the grand mean and square it. You get the mean, and then you get the number in the second group, you get that group mean subtracted from the grand mean and square it. So 3 times the quantity 2 minus 4 squared plus 3 times the quantity 6 minus 4 squared. If you do the 2 minus 4 first, you get negative 2. Squared is 4. 4 times 3 is 12. For the other one, it's 6 minus 4. 2 squared is 4. And then times 3 is 12. So the sums of squares between groups, and you want to make sure you write out that it's the sums of squares between group, you should get the final answer if you add these two up. You add them up, do the hokey pokey, and turn yourself around. You should get the sums of squares between group. Make sure you notate it that way as 24. I hope that makes sense to you. You may have to listen to this more than once, but that's the basic idea. And then you have the sums of squares between groups, but how do you go from sums of squares to variance between group? You need to get the degrees of freedom between groups, and the simplest way to do that is you have to start with how many groups do you have? You have 2 groups. So you take the number of groups minus 1. So the degrees of freedom between groups is 1. Sums of squares between groups is 24. Degrees of freedom between group is 1. The final step is to compute the variance between group. Variance equals sums of squares between group over degrees of freedom between group. 24 over 1 is 24. So the variance between group is 24. You may have to listen to this more than once. Hopefully that makes sense for you, though. Okay, let's go for the next one. If you're going to get an F score, you need the variance between groups. You've got that, but you also need the variance within groups. The variance within groups reflects the spread of scores within each group. So the way you do that, the variance within group is equal to the sums of squares within group over the degrees of freedom within group. How do you get the sums of squares within group? For that, you basically summate each score minus the group mean squared. Each score minus the group mean squared. So in the first group, 1, 2, and 3. 1 minus 2 plus 2, 1 minus 2, quantity squared, plus 2 minus 2, quantity squared, plus 3 minus 2, quantity squared. You do the hokey pokey and you turn yourself around, and what do you get for the sums of squares within the first group? 2. Because any 3 consecutive scores, the sums of squares are always 2. How about the second group? 5, 6, and 7. Can you figure out the same thing there, that the sums of squares within the second group is also 2? So if you add those up, you get sums of squares within the first group 2, sums of squares within the second group 2, the sums of squares within group, the total amount is 4. And then you have to get the degrees of freedom within group. Degrees of freedom within group is basically how many people do you have in the first group? 3. So you have 2 degrees of freedom there. How many people do you have in the second group? 3. How many degrees of freedom there? 2. So your degrees of freedom within group is 4. Your degrees of freedom within group is 4. It's basically the number of groups you have times n minus 1. So you get 4 there. So sums of squares within groups is 4. Degrees of freedom within groups is 4. So the variance within group is 1. I think I'll stop this recording here because we're going on for a bit. Thank you. Bye-bye.